Hi, chemists. So we've been working on doing gas laws calculations with P1 V1 over T1 equals P2 V2 over T2, which is for changing conditions. In this video, you're going to learn how to do gas laws calculations using the ideal gas law, which relates those three variables plus number of moles, so that's N, when conditions don't change. So what if conditions don't change? How are pressure, temperature, volume, and number of moles related under constant conditions? So here we go.
All right, so you've already seen all of these variables before, but let's just quickly review what our variables stand for. Okay, so in the ideal gas law, PV equals nRT. P stands for pressure, V stands for volume, N stands for the number of moles, R stands for a constant, which we're going to talk about in just a sec, and T stands for the temperature. And remember, that's always going to be in Kelvin, so you got to convert if it's in Celsius.
All right, so what the heck is this R thing? R is the gas constant, and it's 0.0821, and the units are liters, atmospheres over moles, Kelvin. It's always going to be the same, so this is a number that you'll just get used to using. One other idea that we want you to make a note of right now is the idea of standard temperature and pressure. So a problem might not give you temperature or pressure. They might just say at STP, or at standard temperature and pressure. Standard temperature is 0 degrees Celsius, which you know is 273 Kelvin, and standard pressure is at 1 atmosphere. So if the problem tells you to do the calculation at STP, or standard temperature and pressure, you're going to use 273 for temperature and 1 atmosphere for pressure. So keep that in mind as we go along.
All right, so let's take a quick look at an example. Okay, so please write this example problem down in your notes. What is the volume of 2 moles of gas at standard temperature and pressure?
Oh, there it is already.
Standard temperature and pressure, right? So you can refer back to your notes if you need to remind yourself of what standard temperature and pressure are. All right, but since the conditions in this problem aren't changing, we're going to use the ideal gas law, PV equals nRT. Okay, so we're going to take this equation and we're going to plug in the values from the problem. All right, so we know that our pressure at standard temperature and pressure at STP is 1 atmosphere. We don't know what the volume is, that's what we're trying to find out. We plug in 2 moles for N. We plug in 0.0821 liters times atmospheres over moles times Kelvin, because that's the value we always use for R. And we multiply that times 273 Kelvin, which is the temperature at STP. All right, so we've plugged in all the values that we already know. So all we need to do is to multiply those values on the right side of the equation together, and we find out that our new volume, or that our volume is 44.8 liters.
It's a pretty big volume.
It's a pretty big volume.
All right. So here's one more practice problem. It's the last one. So write this one down. At what temperature will 1 mole of gas at 2 atmospheres occupy a volume of 20 liters? So this problem is a little bit different from the last one. Instead of calculating volume like the last problem, they're asking us at what temperature. Nothing's changing here. Everything's staying the same. So we're going to use the ideal gas law again, and we're going to plug in. So 2 atmospheres is our pressure, 20 liters is the volume, and it's already in liters, so no need to convert. Our number of moles is 1, R is always 0.0821, and we don't know what the temperature is. That's what the question is asking for, so we'll just leave T right here in the problem. I'm going to multiply on the left 2 times 20, which gives us 40 right here, and multiplying 1 times 0.0821 gives 0.0821, times T. We want T by itself, so I'm going to divide both sides by 0.0821, and 40 divided by 0.0821 is 487 Kelvin. The question doesn't specify a unit, Kelvin or degrees Celsius, so we can just leave it as Kelvin in this problem. If they did ask us for degrees Celsius, we do 487 minus 273, and we find that that would be 214 degrees Celsius, so pretty warm.
All right, that's it for today. It's a pretty short one. We still want you to do the same thing that you're always going to do. So write a quick summary of what you learned in this video. And then write down any questions that you need to ask in class tomorrow, and we'll answer those for you then.
All right.
Thanks for watching.
See you guys later. Bye.